First, we want to define a function. So as my definition for a function, I'm going to write that a function is a rule that relates two sets of numbers. To illustrate this, we're going to take an equation. For example, y is equal to 2x plus 1. This equation would be something that you might have seen back in middle school or early high school when you were learning how to graph an equation. If you were given y is equal to 2x plus 1 and you were asked to graph the equation, you likely would have made a table of values or a t-table. As you may recall, you were allowed to select any x values that you wanted, and then you would plug those x values into the equation to solve for y. So suppose I choose 0 for my x value. Then what I would need to do is come to my equation, and in place of this x, I would need to place a 0. So my equation is now going to become y is equal to 2 times 0 plus 1. 2 times 0 is still 0. And when we add 1, we're going to get an answer of 1. And so we know that if we plugged a 0 into the function, that we would get a 1 for the y value. Then we would choose another x value. So maybe I choose an x value of positive 2. And then I would go to my function, and in place of the x, I would substitute in a positive 2. So my equation would become 2 times 2 plus 1. 2 times 2 is 4, plus 1 would give me 5. And we'll do one more. So let's say that we chose as our x value -3. And so if I was evaluating at -3, I would come to my equation. In place of this x, I would put a -3. So I'm going to rewrite it down here. So 2 times -3 is -6, plus 1 is going to give me -5. And if you were in an early algebra class and you were graphing your equation, the next thing you would do would be to plot those points and then connect the dots to make a graph. But what I want you to realize is that you could continue this process of choosing x values and plugging them in pretty much forever. So I'm going to put a ... on both sides of this to indicate that we could continue with this process. Now, with that in mind, let's go back to our definition for a function. So we said that a function was, first of all, a rule. So this is my rule. This tells me that whatever the x value is, I'm going to multiply it by 2, and then I'm going to add 1. So when we talk about a function being a rule, we're talking about the equation. It also says that the function relates two sets of numbers. So I'm going to circle all of these numbers, and this is going to make the first set of numbers. And if you note, all of these numbers are x values. So these are going to be all x values. And when we talk about the set of all x values, we are talking about the domain for a function. So I'm going to come back over here to my important terms, and I'm going to write for the domain the set of all x values. So that's the first set of numbers. I also have a set of numbers on this side. So this is going to make the second set of numbers. Now, if you notice, these numbers are all y values. And we call the set of all y values the range. So I'm going to put that down for my definition of the range, the set of all y values. So again, a function is a rule that relates the x values to the y values, or the domain to the range. So our last definition that we want to define is what's called function notation. So this just means that we need to talk for a minute about how we note that we have a function. There's one significant difference between the way that we write an equation and the way that we write a function. If we're talking about a function, instead of the y, we will typically see it written f of x. So instead of getting an equation that looks like y is equal to 2x plus 1, we would get a function f of x is equal to 2x plus 1. You will also see the f of x written here instead of the y. So what you want to note on the function notation definition is that f of x is the same as the y. And so sometimes I'll have students who'll tell me, I don't like to deal with the f of x. If you don't want to deal with the f of x, you are free to change it back to a y. But the f of x is the notation that says that we're dealing with a function.